Okay guys, today we will learn about influence line diagram for truss or truss. So let at first take a truss. L1, L2, L3, L4, L5, L6 and L7, U1, U2, U3, U4, U5, U6 and U7. So this is a truss. And the length, overall length is 6L1 and this height is H. This is A and this is B. so at first we have to calculate for, we can calculate for top chord or bottom chord. At first we will calculate for top chord. What we will calculate? The forces in the horizontal member, that is U1, U2, U2, U3, U3, U4, this. The axial forces, it may be tension, it may be compression. Okay, let's see. We'll calculate the at first the forces in the horizontal member. So at first we will take the top chord. In top chord, you will see there are different member U1, U2, U3, U3, U4. Okay. So to find the member forces of all these member, we can calculate all these by different methods. There are two methods specially. One is we can use method of joint or method of section. So at first we take this one member U2, U3. U2, U3 member. And U2, U3 member is this one. So take this section. Now we have to put the load in this truss. Taking this section, this is one section, and we'll put the load. If we put the load on the left side, then we have to take the right side. If we put the load on the left side and right, to take the right side. Simple. Okay. If we take load on left side of section 1, if we take load on the left side of section 1, this is right side and this is the left side. So we will take right side for calculating member forces. This section means I will draw for one, but later I will not draw this one. This one. And there are, but I will don't draw this. I will take only you to this. Only the tensile forces. We assume only the tensile forces. So So we want the force of this member u2 u3. So we will take moment about this point, moment about L3. If we take moment about L3, then what will be the, all this force will be 0 because it is passing to this point. Then only this is the force, that is P u2 u3 into h, because this is the h distance, and there is one forces RB in the last of this truss, and RB into this distance, it will be L7. So this is what is, it is clockwise, because this is force and this is the distance, so it will be clockwise, and this is also clockwise, so it will be in same, RB into L3 L7. So but you have to keep in mind one thing, that is the load are varying, they are not at a constant point, they are varying from L3 to L7. Okay, this is very important. Equal to 0, this is the overall moment equation. Now m p u2 u3 equal to minus RB L3 L7 means the load may be from L3 to L7 by h. And what is this RB into L3 L7? What is RB into L3? This is the moment, no? Moment at L3. Yes or no? Moment at L3 by h. So if you consider the load on the left side and taking the section right side, we are getting the member forces Pu2 U3 as minus M L3 by h. If we take the load on the right side, then we have to take the left section, and by doing the same process, we get the same value of Pu2 U3 equal to minus ML3 by h. You can do it. You will see that you will get the same result. So now as we get the forces, we have to draw the ILD for L3 U2 U3. So recall what is the ILD for ML3 moment. If we recall ILD for moment, you will remember that its value is AB by L. Yes or no? AB by L. So if this value is AB by L, then this one is ML by 3. Means L at 3 means at this point, L3 point. So what is the distance? A 4, oh sorry, L1 2 L1, B 4 L1. So its value will be, first is 2 L1, then is 4 L1 by L. Means this value is by overall L1. L1 means, what is the value of L1? L1 value is what? 6 L1. L is 6 L1. So you can see. So its value is 4 by 3. Now we will draw ILD for this is the ILD for U2 U3. ILD for U2 U3. And its value, what will be its value? What will be its value? Its value is this minus ML3 by h. What is ML3 value? There is 4 by 3. 4 by 3. L1, there is L1. So this is the value. And as it is negative, so it is negative, means compression. Compression. So this is the way how to find the value of the top chord. By the same process, we can calculate the value for U3, U4, U1, U2 by taking the method of section at any part. This is the way how to find. I just calculate for only U2, U3. You can calculate for U3, U4, U1, U2. It will be same. The process is same. Exactly same process. This is for a top chord. And if you have to calculate it for a bottom chord, that is L1, L2, L2, L3, L3, L4. We'll see how to calculate for bottom chord. Okay. For bottom chord, I will take another page. So this is the figure. We have to calculate for bottom chord. Bottom chord. So for bottom chord, at first we will see that first we will see this point for this section L3, L4. Locally L3, L4. Now load on the left side. We will put the load on the left side, then we will take the right hand part. Okay, are you getting? If we take the load on the left hand side, then we'll take the right hand side. Means this part. We'll take this part only. And same way, by taking moment, we'll find the forces. So load on left side, then what will be, it's something like about this is U4, this is L4, and only there's something like that. We don't need all this, we need L3, and it is U3. Okay, now L3 U3 into H and RB into U7 U3. As all these are forces are passing, and here is one force, so this U3, which we have to calculate. As all these forces are passing by this point, all these forces are passing by this point. So what will be the reaction? P into L3 L4 into H, P into L3 L4 into H. We will take the moment about U3. Moment about U3. Moment about U3. Are you getting? There is one U3 now. We have to take the moment about U3 and are you getting? Moment about U3. What is the, this is P L3 L4 into H. This is clockwise. This clockwise. And there is an RB. And what it will look clockwise or anti-clockwise. Just this is force in upward direction. RB is in upward direction. Okay, and the distance from U3. This is U3. So it will be in anti-clockwise direction. Are you getting? And L3 L4. This is L3 L4 is in this direction, and this is the force. This is the distance H. So it will in clockwise direction. So both are in opposite direction. So RB into U3 U7. So PL3 L4 equal to RB into U3 U7 by H. So it is now positive. In earlier cases it is negative. Now so RB into U3 is MU3 by H. And you know how to draw the LD for MU3. So now I will directly draw. Okay, let's. All these are ILD for moments for MU3. So this will be AB by L. So what is U3? Okay, let's see U3. This one L3 this is 2L1, 4L1 by 6L1. Same. 2L1 into 4L1 by 6L1. It will be 4 by 3L1. And if we draw the ILD for if we draw the L3 L4, then it will be 4 by 3L1 by its. Now this is positive value, the value is positive, so it is positive. Similarly, we can calculate for L2 L3, L1 L2, L1 L2, L2 L3 by means taking the same process, method of section. We can calculate the value of all the horizontal member, and by this way we can calculate ILD for all the member forces, which I had already shown you how to calculate the value. I hope you are getting what I want to teach you. Okay, thank you.